Genaille Lucas rulers are similar to Napier's bones in that both of them can be used to determine the result of a multiplication. But unlike Napier's bones, you don't have to remember the result of a carry from column to column. Also, there is a different form of Genaille Lucas rulers that performs division as well as a multiplication. We'll illustrate how the ruler works by performing an obvious multiplication. 501 multiplied by 1. We start here by laying out all the rulers with the columns involved. We start with 5, which is at the very top. And next one, 0. And then finally we have 1. Nice and slow here. We can have a fourth ruler, which can be used to store any possible carry-outs that may occur because of multiplication, but it obviously won't apply for this case because there's no carry-out. So now I will speed post the operand 501 in the board here, 50, and then we have the 1 here. How do we determine the multiplication with the other operand, 1? We do this by looking at the rows. The first row is for the first operand, so we follow the arrows and we get 1 for the first result. Next value is 0 for the product. And then follow the arrow, we get the 5. In other words, 501 times by 1 is 501. We're going to have another example to illustrate and multiply the operands 501 times 3 to give you a better idea of how you can use Genaille Lucas ruler. We already have the rulers here for 501, and we count down to the third row here for the second operand, 3, and we read that first number as the first result. Then we follow the arrow to the next value, 0. Follow the arrow to the next value, which is 5. Follow the arrow to the overflow one, the carry is 1.
256 times by 8, which yields the value of 2048.
Because the first operand is different, I'm going to go through this slowly again. So we have the ruler set for the 2, 5, 6 on the wall.
Ruler for the 2, the ruler for the 5, the ruler for the 6, and plus the index posted on the wall. Multiply by 8, count down 8 rows. 1, 2, 3, 4, 5, 6, 7, and 8. Read off the result from the top value of the row, and that's an 8. We then follow the arrow to the next ruler in the next column, and we get a 4. We follow the arrow to the next column, and that yields a 0. Following the arrow to the final column, the index column, we get a 2. Now with rulers, you might ask, why are the values sequential, increasing by 1? See the index increasing by 1? We see one of the rulers, the successive values increasing by 1. We see the answer to that when we perform some multiplications and look at the carry out value as you perform multiplications 2 times by different values. 2 times 2 is 4, carry out 0. 2 times 3, the result of course is 6 of a carry out of 0. 2 times 4, the result is 8, carry out of 0. 2 times 5, and the result is 10. Now we have a carry out of 1. The carry out has increased by 1. That illustrates an example of why the numbers successively increase and increase by 1. Just to show some other values to pound home the point, we've got 3 multiplied by successive values. 3 times 2, 6, carry out of 0. 3 times 3 is 9. Carry out of 0. So carry out still 0. 3 times. The next value is 12. Now the carry out's increased by 1 to 1. 3 times 6, 18. Carry out of 1. Go to larger values beyond 1 just to make sure you're convinced. 3 times 7, 21. The carry out is 2. So it's increased from 0 to 1 to 2. And in case you missed it, what I said, it goes 0, 1, 1, 2. And that's why the ruler values and the index value successively increase by 1. Although there's many resources that indicate how the rulers work, there aren't many resources that indicate how they're designed. Why are they designed the way they do? So now you've got knowledge that no one else has on the internet. Good for you.